In this lesson, we are continuing looking at rational exponents, but let's first review some of our exponent laws. When you're combining and multiplying two bases that are the same, but the exponents are different, you would combine them by adding them. So it would look like the following. We would have x, and it would be m plus n. The quotient law would state that when dividing, we are going to subtract our exponents. So it would be x as my base is going to be m minus n. The power of a power law states that when you are combining them, you would then multiply the exponents, where it would be m times n. The power of a product law would be that we could separate them and do x to the m power and y to the m power. Here, the power of a quotient, basically my x to the m power all over y to the m power. Integral exponent, remember when you're writing it, you're going to take it and flip it, so it's 1 over x to the m power, so it loses the negative sign and now becomes positive. And in this particular instance with your rational exponents, remember the x is going to be written within your radical, the n would be whatever your root is, and the m would represent your particular exponent. And then also you could write it as the following, where you would have n root of x to the m power. And remember, we could also write this, if we were to flip it, we could have x to the negative m over n, where basically everything would be over 1. So we could have 1 over the n root of x to the m power. Now, what we're going to do is we're going to continue and we're going to write several examples of powers as a radical. So if we were to go through and look at several examples, for the first one, if we have x to the 1/6 power, remember when we write this as a radical, the 6 represents what my root is, so it's going to be the 6th root of x. If we had negative y to the 5/4 powers, it would be, we could write it where I would have my negative y on the inside raised to a power of 5, however it's the 4th root of that. If I had negative z raised to the power of 5 over 3, I could also write this as the cube root of negative z to the 5th power. If you had something that had a coefficient involved, such as the following, 5t to the 3/4 power, remember the 5 would be represented out in the front, so it would be the same as 5. Then I could consider what this particular exponent represents, and it would be the 4th root of t to the 3rd power. However, if we had 5t to the 3rd 4th power, we could write it as follows. Everything goes inside the radical that's raised to that particular exponent, so it's the 4th root of 5t, and obviously everything on the inside therefore would be cubed. Now, if we were going to continue to write each of the following as a power within an positive exponent and then also as an entire radical, let's go through some examples of those. So I'm going to write this one first as a, and a is going to be x to the 3/2 power times x. So when combining these, I can simply turn this into my radical. It's a square root of x to the 3rd power times x. So therefore, when writing them together, basically it would be x times the square root of x cubed. Let's go to the next one for b. If I had y in the 1/3 power divided by y to 5 over 3. If we were to look at this and try to write it, because we're dividing, and if we look at our quotient law, I know I can do y of 1 over 3 minus 5 over 3, and that would give me y to a negative 4 over 3 power. So therefore, because it's a negative power, what's the first thing we could do? We can go ahead and we can actually flip it, where it's going to become 1 over y to the 4/3 power, and now I can write it into a radical form. So therefore, it would be 1 over I could have the cubed root of y to the fourth. And being that it is flip-flopped, we could actually flip it back up and make it negative if we were to write it as an exponent. But it does say to write as a positive exponent. So basically, these two would be my final answers as in a positive form and then also in a radical form. But it could look like this in the long run. It could also be written like that if it was asking for a negative form of your particular answer. Okay? All right, maybe we could look at some other examples. So now what we're going to do is we're going to reverse it, and let's look at writing radicals as powers rather than writing powers as radicals. So if we were to take a few examples to begin with, if I had the cube root of a to the fifth, we now know that this is simply going to be written as a, where my exponent goes on the top, 5 over 3, because 3 represents what my particular root is. If I had the fifth root of a squared, it would also be written as a 2 over 5. If I had the square root of a to the ninth power, this would be the same as writing a to the 9 halves power. And the last one, if we were to look at, if I had 1 over the square root of a to the seventh, being that it is below within that fraction bar, I could go ahead and we could first simplify and do a to 7 over 2. And being that it's down below, we could raise it up and it would become a to the negative 7 halves power. Okay? All right. And at times you might see some things that will be written as follows. If we still had to write particular things as a power and then evaluate, let's say you see this, the square root of the square root of 1296. Well, how is it that we go about solving that? Remember, the actual square root sign is simply saying that it's raised to 1/2 power. So I could take this and we could rewrite it. Let's start with the piece on the inside. And I could rewrite it as follows. The square root of 1296 and raise it to the 1/2 power. But now we could take the whole thing in general and then do it again. So if I had 1296 and this is raised to the 1/2 power, we could then take the whole thing again and raise it to the 1/2 power. And if I go back to my general rules of a power, what could we do at this point to combine them to get one single power? If I'm looking at it, we could actually multiply these two, and it would be 1296, and 1/2 times 1/2 would therefore become 1/4. So my final answer would be 1296 raised to the 1/4 power. And I could also note that if that was the case and we took the actual fourth root of it, we could continue to solve it. But in this particular case, we're just going to leave it as my final answer as 1296 raised to the 1/4 power. Okay. Let's look at another example. I'm going to go ahead and I'm going to erase this to give me some room. So if we took, let's say, 1 over the square root of 169, and I want it written as a power, and I want you to evaluate it, we could continue from there, and I could write it as 1 over 169 to the 1/2 power. And being that it's written below a fraction bar, I could lift it up, and therefore, if I flip-flop it, I have to change it, my exponent, so therefore it would be 169 to a negative 1/2 power, and that would give me that final answer for that. And one more we could look at. Let's say that I had, let's say we had the cube root of the square root of 64. Well, let's first go ahead and we can take it and we're going to have the square root of 64 raised to the 1/3 power. And therefore now if I'm looking at it, we can go ahead and evaluate this. Let's change this to a fraction. So if I have 64 raised to the 1/2 power, and then we can take it and raise it to the 1/3. And because of our power of a power rule, I can multiply them together. So 64 1/2 times 1/3, therefore gives me 64, and 1 over 2 times 3 gives me 6. So therefore, is equal to 6 square root of 64. And then you could continue to evaluate that if needed. Okay? And that's pretty much it as we continue. So what I would like for you to do now is to continue with your practice problems. If you need help, please seek help during Flex Block from Mr. Tillman, Mr. Wall, or Ms. Fawcett so that you can get the help that you need in order to be successful in this assignment. Good luck!